Hi there, everyone. Sorry for the 2 minute delay, or in this case, 3 minute delay. We're about to get started with this webinar on capacity planning for MongoDB. My name is Norberto. I'm a technical evangelist at MongoDB. These are some of my contact details if you guys need to reach out for any questions or any things that might occur to you that you'd like to see better discussed. More than happy to help you out through that. So today we are going to look into some of the topics around capacity planning. What is this capacity planning? Why is it important? Which resources are affected, and how to do it well? So when we're talking about capacity planning, especially for a database like MongoDB, what are we talking about anyway? We can define the capacity planning as a fine art of picking up your requirements, what your application needs to do, and how it needs to be done, and transforming that into the resources that they actually need, or we actually need to support those requirements. So let's say that we are preparing for a launch. Everything's okay, tests have been done, the code seems good, so the developers say. We are feeling very, very comfortable about the feature set, about the user experience, all of that we are ready to deploy. So how should we do it, and which kind of things should we be considering for that deployment? First of all, we need to think about our requirements, right? So the first requirement that all applications need to consider are the availability. We need to consider our recovery time objective. We need to consider our recovery point objective. How are we going to deal with failovers? How are we going to deal with continuously keeping the service up and running? How are we managing everything that can occur to our application during the life cycle and during the normal execution of that application? The other thing that we might want to consider is the throughput. How many users are we going to have? From those users, how many of them are going to be constantly reading from our site or from our application? How many are going to keep on writing to that application? What's our peak throughput? How many operations per second? How many per day? How many per month? All of these need to be conceptualized because at the end of the day, if we're talking about MongoDB and other databases, this is where all of your data is going to be stored. And in any point in your application, you're probably going to need to fetch information from that. And also, one of the other aspects which is very, very important to keep in mind is how about the responsiveness? How is our application actually supporting the functionality that we want to do? Is our application taking too long to build a feature or to reply to a user? Is this feature that we just added, is it responding in an appropriate time? How do we deal with peak times? How do we deal with latency on those higher volume charges that our application is going to be submitted? These are things that we need to think about when we are starting to plan our capacity support in our infrastructure. So if we think about the resources, we live in the world of the von Neumann's computer, where we have the memory, control units, algorithm logic units, accumulators, and we also have in and outs, I/O, basically. And this today translates to these four different resources. We have CPU to use, we have storage layer to store and persist data, we have memory to hold data, to make sure we have the computational power and the memory bandwidth to support the real-time applications and data flows. And obviously we have network, because we don't conceive applications for a single box anymore. We conceive them to support millions of users worldwide for applications, our websites, or even our internal users. We need to have consideration in all these four domains. So at the end of the day, capacity planning is around balancing your generic and most important requirements, which are around availability, throughput, and responsiveness, and which resources are there to support all of those. So when we talk about storage, we are talking about size, IOPS, we are talking about the size of the data, the data and loading patterns. When talking about CPU, we talk about the speed of the of the CPUs, how many cores, how many parallelism, how many concurrency requirements do we have. In memory, we are talking about our working sets. How much data do we need to keep live in our system to give good responsiveness, how to give a good experience to our users. And obviously, when we're talking about network, we're talking about latency and throughput. How much data can I throw through the pipe? How much time does it take to reach the other end? And this is quite important, especially if you are in the ops and DevOps or sysadmin scenario. You need to think about this very, very well, because you are the guy which is responsible to keep the uptime running. You need to make sure you're maintaining the application running, that no server goes down, or at least not the application itself never goes down, never goes out of service. Once we launch, we have to think about, things that we don't want to be responsible for. First of all, we want to keep our jobs. Obviously, we don't want to be the responsible for a website to crash, or at least to be badly defined or badly sized. And we want to meet the business needs of our users' expectations. If a website is constantly down, probably the user experience is not going to be great, and probably we're not going to be responding to their users' needs. So probably we will have a big trouble justifying that business. We don't want to be the goat at the end. We need to make sure that everything is running properly and everything is working according with the expectation. We want to avoid situations where we are underloads, where we basically don't have enough capacity, where sometimes these things happen, where we get overcapacity, and these things exist and they are common. They are not so much as something that happens from time to time. Sometimes when the systems are either not properly designed or either they've been in flux with so much throughput or so much success, systems need to be designed to support this growth. They need to be able to get to the demand that people require. But you also don't want to overspend because, well, you have limited budget, you have limited resources, so we need to figure out a good balance between what you can offer to your users and what your users are going to expect from you. So we need to take into consideration this important aspect. First of all, which capacity are we going to be running with? Are we going to, in which situations are we going to be under capacity, over capacity, or just right? We also need to have good prediction models. Is it going to be user per loads, ops per request, system behavior? All of these things need to be considered when we are doing the allocation of our resources to hold the capacity that we need. And obviously, one important thing is that our applications are not stale over time. They change. New requirements are added, new versions of the software will be shipped, new systems will be deployed to new geographies, so we need to adjust to that. So attending the change of velocity is also a very important thing. How data is going to be allocated, how it's going to be provisioned, the minimum viable product in terms of how many features do we need to keep the system up and running, or what kind of future releases and roadmaps do we have in mind. And one essential issue is when. Well, you don't want to do it too early because then you're going to block in the application development in your features due to some sizing decision that you made or some resources and capacity decision that you made. But you also don't want to do it too late because you need to launch in some point in your life cycle. And you need to be prepared to launch, and you need to be prepared to accommodate the resources for your application so your users can have a good experience. But also very important is that you need to use this as a process. You cannot make sure that, at least it is impossible to predict with exact certainty how your new features are going to be affecting the load and the capacity that you need. So you need to run this exercise in an iterative way. You need to revise your capacity every time you're going to scale up, scale down, you're going to launch a new version, or your application is going to be subjected to a new lifecycle. So when we're talking about resources, how can we see which resources are going to be affected, and how can we deal with them, and how does MongoDB uses those resources? So when we're talking about CPU in MongoDB, we're basically using that for non-indexed data. We're using that for sorting, aggregation framework, for MapReduce. We're using that to compute the fields, the nesting fields, arrays, and that docs. And all of these are applications, or at least features of Mongo, that will definitely be using a lot of CPU. We are about to launch a new storage engine in our 3.0 version, which will come with WireTiger. And this is a new storage engine that changes a little bit provokes a little bit of a shift on the CPU usage. I'm not going to be spoiling you with the release in the webinars that they're going to specifically talk about 3.0, but I want to raise this issue because it's going to be a very, very dramatic change in how we use, for example, this resource. If you use a storage engine like WireTiger, you will definitely going to need a lot more CPU. You're going to have finer locking granularity. You're going to have more concurrency, which will lead to eventually more CPU usage. Network. So we live in a distributed computational environment, and this basically means that we have a lot of different resources allocated in different machines, different data centers, spread across different regional areas. So network is essentially a very important resource that we need to understand. Network latency affects the write concern, for example, that we are using, the read preferences that we might be using from MongoDB, and obviously the bulk in batching and loading processes. Throughput is also a very important thing because basically this determines the amount of bytes that we can ship through the pipe for each given instruction. So the updates and the write patterns will be affected by the throughput that you are available. And the reads and queries will also be affected by it. Our throughput will be affecting the amount of writes we can do per unit of time, for example, the writes per second. The same thing will affect the reads in the queries. But there are things that we should consider when we're trying to use these resources in terms of network. When we're doing latency, we should consider the write concern that we are using. If we have a very low latency system, probably we can have higher durability using a higher write concern. In the opposite, probably we'll only want to confirm on the primaries to make sure that then the data will replicate it, but not affecting the resources or not affecting the functionality that the application actually needs. When we're talking about read preferences, using nearest on a very slow network or with a high latency probably will affect a lot the results and the experience of your users. And when we have low latency, both write operations will probably not see so much of a throughput enhancement, but with high latency networks, probably you'll see a lot of benefit because you will be shipping more instructions in a bulk write operation and not needing the round-trip TCPs to wait for all the confirmation. On the throughput, using set operators on the update operations is critical. A smaller amount of information we are piping in, the best we're going to be using our throughput. So if we have low bandwidth, this will be a good optimization to be using. Also, for the reading and selectivity of our queries, if we have very, very low bandwidth, filtering out the fields to the minimum that we need and we require, probably the best use of our bandwidth. We also need to think about storage. And storage, well, it's a database. Eventually, you will need to persist data. And on storage, we need to understand basic patterns of storage. Is this going to be used for the active data? Is this going to be used for the archival data? Which loading patterns are we going to use? And which integration are we going to be using with our BI tools, in our reporting tools, in our data warehousing tools? The other thing about storage is the capability that we are adding up to our infrastructure. So if you think about just, for example, the IOPS that normal RPM or HD disks can support us. So in a 7200 RPM SATA disk, you can get around 75 to 100 IOPS on those disks. If you go to our 15,000 RPMs, then we can reach between 175 and 200. But if we consider, for example, SSDs, we completely dramatically change the number of IOPS that we can add to our storage capabilities. So this is something that we definitely should think of when we are designing our infrastructure. Obviously, today we do a lot of the cloud computing. So, for example, in Amazon, you should also consider what we can get. On EBS normal disks, we can have around 100 IOPS. When we're using Provision, we can get up to 2,000, according with our budget and according to how many Provision IOPS we're going to use. And obviously, with the new SSD, EBS Provision IOPS, we can get a little bit more with approximately the same cost. So it's definitely a good choice for storage capability. Obviously, we can go even further, depending on how deep our pockets are for storage. And if you're using like Fusion IO disks or even violent memory ones, we can get a lot more throughput. But obviously, this comes with a cost. Higher IOPS generally mean higher cost. So we need to work out how much data we need to write per unit of time. This will define basically the number of operations that we are going to throwing down the storage and the persistency layer to make sure that our database keeps up to the throughput rate. More data generally means bigger indexes, which then requires more storage. And don't forget one thing, MongoDB stores information into documents, so we store the full structure of the document every time we use it. So think about that when you're using MongoDB and when you're defining your schema design to store your information. On WireTiger, which is coming, well, we're going to add up some nice things that will help save some storage, but also consider that when we compress, for example, we're going to be using more CPU cycles. So have that into your calculations when you are determining the capacity that you need. Good thing is that we're going to be able to compress separately documents and indexes, which probably will make us better suited for different use cases and more scenarios. We're going to be using LSM trees on that storage engine, and this will make a significant difference on how we use the storage layer if using this storage engine. Memory for MongoDB is generally the resource that we require the most. Basically because we have a VM map file, the storage engine, which basically is a virtual memory map file system, where basically all the data that we use will be mapped into virtual memory and then used by the operating system according with the scheduling and according with the page forwarding. But you need to also consider there are certain operations in MongoDB and other databases that will require a lot of memory. Sorting generally is one of them. The aggregation framework also, and the messages also use a lot of memory. And to deal with connections, MongoDB also requires a lot of memory resources. So you need to consider how many concurrent users are we going to have, how many connections are we going to have to our database when we are thinking about the memory. When we need to think about the sorting operations, the aggregation operations, and so on. So as an explanation of how the thing works, if you have the database files, those database files will be mapped into virtual memory. Those mappings are going to be cached into pages. The pages will be composed by extents, and those extents will be adding there the documents that we store and use from the application. Make sure that you have this in mind as well, that data and indexes are both memory mapped into virtual address. Data accesses are also paged into RAM, and the operating systems, they evict data from the RAM using the LRU, least recently used. So this will impact as well the way that our memory is going to be used and how the way that MongoDB will be reacting to the queries and to the operations that we are going to throw into Mongo. On WireTiger, we're going to also add up a couple of new improvements. Well, WireTiger storage engine uses a cache size that we can configure. We can also configure the checkpoints on which the eviction of that page or the flushes of those pages that are used are going to be stored into the persistency layer. So it's very important to have that in mind, that even though the WireTiger will use more CPU and probably will have compression and a lot of other things that will make it a little bit different in terms of capacity, it will still need memory to use all of the operations. So how to do it well? Well, first of all, we need to determine our working sets. And this is very, very important. Our working set is basically a measure of different aspects like how many data we are actively asking the system to react with, and the indexes that we need to be required to support the queries that we need. We need to use good measuring monitoring practices because your working data set will change over time. As you get more users, as you get more requirements, as you get new features, these requirements, this working set might change and morph into something different from what you initially expected. You need to plan ahead but to be flexible. You should not be very, very constrained on the resources that you're going to use. Make like room for growth, make like room for improvements as well. And this basically gets into a cycle of iteration where you need to review your requirements, which will lead to reviewing the capacities you have and that you need to support those requirements. So what is this working set? It's basically a number of active users on the system at any one time will be equal to the number of distinct pages accesses per second. This is a metric that we use because it's very simple to understand. If I have a lot of people asking for different records or different documents in your application, that information will need to be pushed into RAM, they will need to be accessed from disk, there will need to be calculations going on the CPU, and this will all affect the working set. And when your working set basically explodes in terms of your RAM capacity, that is a very, very important moment where you need to think about scaling the system. Either adding up more resources to the individual computational nodes and scaling it up, or basically scaling out using sharding or some other, using sharding to spread the load across different instances of MongoDB. So let's think about, for example, the scenarios where disk and RAM will be used a lot. So imagine that you have 4 distinct pages asking for 4 distinct pages per second. If all those pages are in disk, well, basically in the worst case scenario, we just do 4 access to the disk per second. But if you have 6 distinct pages and you only have room for 4, well, you probably need to ask for some other page. That page will need to be evicted and then get the second one. So in the worst case scenario, every access will basically mean a different opt. This will probably reflect itself in this small graph that we have here, where we see a correlation between the number of million of ops that we do from MongoDB and the number of page faults that are going to be happening. Every time you ask for data that is not in memory, a page fault will be emitted, the eviction of memory will occur, and if you don't have enough size in your RAM to hold all your active data sets, you will start to see a slowdown on the number of queries per second that your Mongo can provide. So think about capacity sizing and think about how much data you are constantly accessing and how much indexes are you going to be constantly using. Make sure you have enough room to grow. Do not be tight on RAM. Do not be under capacity in your system in terms of the resources that you're going to need for your working set. If your working set is larger than your RAM, you probably need to have more resources. Chart then. This is what charting is there for, is to allow you to grow your system and keep up with the growth of your data set and keep up with the same performance as having one machine or several. And also think about the architectural definitions that you need to consider. Lots of different instances, the big ones, or a few of them which are very, very, very big. Things that will affect as well the way that your working set is going to be used is, am I using local disks versus central storage? Because if we are doing a lot of evictions, we're doing a lot of page faulting, we basically need to have a very, very fast access to our data. If they are in local disks, probably they're going to be faster than if they are in central storage at SAN or something like that. And obviously, you also need to consider how many copies of our data we need for high availability reasons. If we have a lot of different machines with the same information, if one fails, another one can keep up with the load and with the workload. If we only have a couple of them and we don't have too many copies, probably going to have less failovers, and this will affect our availability. Measuring is an important part of this game because we need to be prepared not only when we are defining ahead, but also when we are in production and supporting the application. And there are particular things that we are going to be very interested in measuring, and there are going to be other things, especially in MongoDB, that we definitely need to monitor. Things that we need to measure are around IOPS, page faults, the resident memory, the number of connections, and obviously the loss percentage. Things that will help you to measure well and to monitor well. Well, you can have IOStat, VMstat for the basic I/O and memory usage of your system. But then MongoDB also has MongoStat, MongoPerf, and MMS with excellent tools to help you monitor and measure all these things. IOStat is well known. Basically gives you per unit of time the number of accesses that you have to your disk. It also gives you an indication of the CPU usage and the load average. It's an excellent tool for us to make sure that we have the right resources per unit, per computational unit, in this case per node, to make sure that we are not saturating the resources too much, or to understand if we are running under capacity to support the functionality of our application. VMstat will basically give us an indication of how much data we are constantly using and how much of that data is actually fitting into memory or needs to be evicted all the time. The number of page faults, the number of active and free memory, it's an important metric to keep in consideration. MongoStat is a quick overview of the status of MongoDB nodes. It allows you to give you the indication on per units of time of several different metrics, from inserts, queries, updates, and deletes, to virtual memory, to resident memory, the active writers for reading and writing, the queues for reading and writing, the network throughput, in and out, the number of connections, and the number of in which amount are they going through time. As you can see, this small snapshot I took from my simple execution, my system. I could easily run 50,000 inserts a second on the new version of MongoDB. We're using very little memory and very little connections. MongoPerf is also a tool that we make available with our distribution that allows you to test perform your system ahead. It will basically test the I/O of performance using MongoDB operations to test how well is it working. It will create indexes, it will allocate space, it will give you in a per benchmarking situation where we constantly raise the number of instances and the number of threads that are throwing data into the disk. MongoTop is another good tool, especially for sysadmins, where you want to understand where am I spending my time per unit of time on operations with MongoDB. It will give you the total per namespace where I'm writing or when I'm reading data from the instance. So if I have a particular collection or database that is consuming a lot of my time for writing, let me see if that correlates correctly with the kind of functionality that I'm supporting. Also, we have MMS. And MMS is a very good tool. It uses MongoDB management system. It does give us a couple of things more than just monitoring. It also provides us with a way of doing automatic backups. It also provides us with a way to deploy our systems in a very easy way of scaling out, adding more replicas, adding more shards, and so on. It's a very comprehensive tool for doing all of the three main operations. And the good thing is it gives us a good indication through time of how the system is behaving. So I definitely, if you're not using MMS yet, and if you have a deployment of MongoDB, I definitely recommend you to have a look to it, because it is a lifesaver for a lot of situations where you want to have an holistic and comprehensive view of all of your cluster. So when you're monitoring all of these, using some of these tools or all of them, you need to keep in mind the key metrics. The key metrics will be storage, IOPS, size of data, how much data we are throwing in per unit of time. You need to think about the memory. Is our system fully allocating memory all the time? How many page faults are we doing per unit of time? Is our memory, our working set fitting into that memory? The CPU, how much CPU are you using? How many cycles? Is all the cores being used? Am I underlagging the amount of time that I have to do calculations? Which kind of operations are going to require more CPU than others? Network is essential to make sure that we have enough latency or low latency to support the good responsiveness of our system. And if we have good throughput, make sure that our application is doing the actual throughput that is needed from the application. And obviously, do not forget about one important thing. MongoDB is just a piece of the puzzle. It will hold your data, it will support your calculations, it will make transformations over your data set. But at the end of the day, you need also to make sure that your application is running as expected. So make sure that you have all your applications well monitored in terms of usage, in terms of application, in terms of responsiveness, not only from the MongoDB layer, but also from the application layer. There's lots of models we can use to make sure that we have a good capacity for our system. We can use the response time on the per load per user kind of scenario. And we also can have the system performance to consider. What is our expected peak usage? What is our minimum usage of the system? These are two different things that probably are around the same metrics, but they are completely different, and they are extremely needed when we are defining our system. We do not want to overspend on a system that is not going to be, which will keep up with the demand for peak usage, but if you think about the minimum usage of how a system needs to behave, you're probably going to be using too much of those resources. The other way around also applies for this performance system matrix. An important thing about all this capacity planning is to make sure that we have a good track of our velocity of change. If we are adding up new requirements and if we need to add up new capacity to our system, there are a couple of things that we need to consider. First of all, there are limitations around allocating new resources to that. There's a lot of data movement that will probably need to be done. if I'm switching it from one box to another, to a bigger powerful machine, a migration will eventually need to be happening. And this takes time. If I'm adding up a new shard or more replica sets to the existing shards, that also will generate some bandwidth, some throughput requirements. And the data itself will need to move, will need to migrate, will need to split in order to support that. So make sure that you have that in mind. Also, allocating these resources, buying the box, asking for the budget to buy and provision with more capacity of your system, generally needs time because it involves cost, it will involve supply and demand, it will involve you talking to your dealer or for hardware or getting a new instance on your cloud provider. And this also will be affecting the way your application will be sized accordingly. And obviously, there's also the improvements that we add up to our software. We need to make sure that every time we add up a new feature or we are capable or we are interested in doing some change in the configuration of how the system works, we limit that to the minimum possible. Why? We want to understand what if a change will, in which kind of impact will that change provoke in your system. So limit the size of any change. If you're preparing a major release, make sure you do it step by step, adding one feature at a time. Probably you want to be increasing that frequency, adding features more often, but smaller ones. Make sure that you are fully aware of the implications of those features. Measure its effects. That's definitely one of the most important things that you need to do when you are adding up new stuff to your system, because it will definitely affect the way that you need to, that your application will react, and most likely than not, this will affect the capacity that you need to support it. And please practice it very often. Do iterative deployments. Make sure that you have a sufficient enough or realistic enough test bed or pre-prod environment to see the changes in effect. So to make a long story short, well, capacity planning, it's these three things. It's very needed. It generally requires a lot of cost handling, hardware specifications and sizing, and involves resource allocation. This is extremely needed to make sure that your project, your application is successful. If you do not have the capacity that your requirements demand, you're probably not doing what you're expecting. It's valid because it also translates those requirements and expectations into experience and functionality. We know for a fact that if our systems do not reply in the same expectation as we promised, well, pretty much we're going to lose market, we're going to lose our users. So make sure you are meeting those demands, you are making sure that the requirements will translate correctly into the experience and functionality that the users are expecting. This is also, the capacity planning also requires a lot of understanding of our application. Do not assume that by just throwing it into MongoDB or any other database that your problems will be solved. We need to measure very, very well which resources we are using and which ones are we definitely requiring. Make sure you have a good monitoring system so you can keep alerts every time that something happens, something changes, and you can a steady improvement and steady view of how your application will change and how your application will model and shape the requirements and the resources that are being allocated. And it's an iterative repeating process. It doesn't stay still. It doesn't hold forever. You need to be fine-tuning it as you go. We at Mongo, we provide a lot of information around how to size this correctly. We do also a lot of other webinars like this one on different other things. Please make sure that have a look into these resources, because most of the times we will find a lot of answers to our capacity planning on these links. Don't forget about our next webinar on migrating from relational databases to MongoDB. We will have a lot of things related to this capacity planning webinar translated into how we adjust to a migration, how we adjust to the changes between different models, how the difference between how relational systems use those resources, and how MongoDB will be using those as well. Obviously, we are also all very excited for our upcoming release, which is coming with new pluggable storage engines, API, improved concurrency, compression around large replica sets, tools rewriting, so many other nice features that we are expecting. And I have a couple of minutes to do a few questions. So if you have any further questions that you don't see responded in this chat, you can contact me again, or you can just type them in your chat right now, and I'll be available to answer some of those. So I have a question around what is the capacity planning for DB backups? Are backup files compressed? Well, depends how you do your backups. But for example, if you are using a normal dump of MongoDB, you're basically throwing all of that data that you are storing into your MongoDB into one single file, which is already in binary format, so not a lot of compression could be done there. The way that you need to understand is when you do a dump of your data, your database is subjected to some fragmentation, and by throwing all of that information into a dump, you'll probably be removing all the fragmentation that exists. Also, from the dump to the database, we need to factor out the indexes size, because when we dump information to BSON, we are not holding the information of the indexes themselves. We are just putting in the metric or the mechanism to build the indexes again when we rebuild or re-import that data. So backup files will definitely not be compressed per se, but they will be smaller in general from what your application, your database size is. Can you provide one example of online retail business using MongoDB? Well, if you go to one of the links that I've shown before, like this one, you'll see a lot of use cases of our customers. And there are several of them which are in the retail business. Some of them are very, very well known. Most of us have already shopped there. So I'll make sure that you guys go through those and see which one of them you can recognize. But they are very, very well known, like eBay or some others, like in the genre. So Mike is asking, in 3.0, is compression an option? Is there a performance hit? Well, compression on 3.0 will be attended by a new storage engine, WireTiger, which has 3 different algorithms to do compression. Again, I'm not going to be a spoiler on the feature set and how it actually works, but just as a heads up, it will allow you to use Zilliq, Snappy, and some other one that I can't remember right now. And the compression rate might be between 30 to 80%. Obviously, when we are using compression, well, we are going to burn more CPU cycles. And this will definitely affect not only the read performance, but also a little bit the write performance than if you're not using any compression at all. So that should be more or less the hits that you get. Ibrahim is asking a question about advantages of MongoDB over Apache Cassandra. I'll mostly want to talk about capacity planning, not that I'm not aware of the differences or advantages of MongoDB, but I'll leave that to other forums in other chances to respond to that. Alessandro is asking, what is the minimum CPU RAM requirements for the development environment with very low availability and throughput requirements? Well, the minimum viable setup of CPU RAM is the one that you are running on your laptop. This probably will do a lot of the application or the requirements that you have for your development environment. But if you want the integrated development environment that you use for integration as well, if your colleagues are all working on different features, you want to see how those react to each other, I would say that you should probably go for a minimum of setting up your working set in RAM. At the very least, your indexes should definitely have enough space in your RAM to hold, and a little bit more of data to that. In terms of CPU, well, it depends on the testing that you are doing, but generally development environments are not heavy in concurrency, so probably you're going to be doing very little operations per second. So the requirements there on CPU will be smaller, unless you are doing a lot of aggregation framework operations, and then there the CPU requirements will be bigger. So count with some amount of that if you're doing those operations. And for very low availability throughput, well, basically how much operations you want to test, how much you want to stress the system. So our Rahman is asking, what would be the optimum buffer size that we need to have as a reserve in typical real-time deployment? Well, my question to you would be, what's your buffer size? Which kind of buffer are you referring to? Because there's different kind of resources that we can use there. Stefano Tralori is asking, would these MongoStat EDC tools work on Windows as well? Yes, the tools will be multi-platform available. So they all work on Windows, they all work on different environments from Linux to Solaris, so they should be all working, and by the way, they are working on all these deployments. So Sean Davis is not seeing MongoPrep in the bin folder. Probably you need to. You can also download it from our downloads page if you don't see it in your deployment. But you should definitely see it on your. If you do a full install, for example, on Windows, you should see all these tools available there. Jean Panigrai is asking, what do you prefer for dynamic changing data sets, having data centers across the globe? What would you suggest for those scenarios? Well, when you have a multi-geographical deployment, what you definitely need to consider is the latency between data centers. It's a generic usage of MongoDB because we have a very nice way of keeping data floating between different data centers. When we have a global deployment, we need to consider the implications on latency and the throughput of those connections. So be aware of that. But given that we can easily spread out through tag-aware sharding and for dislocated replicas, we can use a very, very nice way of defining a very resilient setup and deployment of our application by using a global distribution. Think about having a replica of your primaries from North American market into Europe, or in your Asian deployment, having the same thing cross-site into the US. So you can easily have that into your setup, into your architecture. Are there preferred platforms to run MongoDB, Stefano? Well, MongoDB is agnostic from the platform, so we want to make sure that we have the best experience on any platform. We do see a little bit of changes between Linux and Windows, for example, but I don't think that that's definitely a dramatic one. It's just a question of how the operating system uses a memory or manages those. So, but there's no preferred platform to run Mongo. Shadad Amini is asking about MongoSniff. Well, basically, think about MongoSniff as TCP dump specific for MongoDB. It will track on your network and it will basically tell us what happens on which package that is interchanging for that node. It will serialize the information that you're seeing from the BSON to JSON if you want to, so you can better see the traffic that is going on. But it's pretty much the same functionality that TCP gives you, but tailored for MongoDB. Alessandro is asking, the 16 megabytes per document is going to be raised in the next version. Having a split big documents or using GridFS have a negative impact on the capacity planning. So the 16 megabytes limit will not be raised, and there's very good reasons why not to. For once, every time we need more capacity, or let's say bigger documents, or let's say, for example, a media file, like binary file, we'll probably need to use GridFS as you mean. And GridFS is not more than a nice, flexible way of storing exactly those types of data formats. Does that affect your capacity planning? Well, what the GridFS will do is basically chunk your documents or your files, let's say, like for example a PDF or a video, into small chunks, small individual files, and throw that into a specific collection called chunks in the GridFS. Obviously, these will take space, and there's a little bit of overhead due to the document model. So if a file occupies 1 gigabyte, you probably need to send a little bit more of that to hold your data into MongoDB. But you have immediate replication, immediate backup, and very co-located data with your metadata, which is definitely something that you tend to like when you're using GridFS. So does it changes the capacity planning? Not that much, but you need to attend the storage to hold all that information, obviously. Stefan is also asking, are there problems or recommendations about running MongoDB on virtual environments? If you go through our documentation, there's a specific sections for example, AWS deployments, where there are some features that you need to not so much tune in, but at least be aware of some of the configurations that we recommend. And if you are in such environment, we generally have specific builds and specific images of already optimized MongoDB deployments. I can definitely recommend you to use those. Okay, so we'll be wrapping up now. Thank you so much, guys, for sticking around and doing all your questions. If we do not provide the full amount, and if we didn't go through all your questions, make sure you keep my contact in line. Please just throw me an email. More than happy to contribute to the explanation or any concerns that you might have around MongoDB. Thanks a lot.